Hello everyone, my name is Paul DeWise. I am a sales engineer here at Forerunner 3D Printing, and today I'm going to be giving you a little bit of a walkthrough of how we set up a build and then run a build and then unpack a build on our Mulit-Jet Fusion machine. This is actually an HP Mulit-Jet Fusion 4200 is the full name of this piece of equipment. So yeah, let's kind of get into it. So this is Magics. This is a piece of software specifically written for doing build layouts for all kinds of different additive machines. Today I have HP platform pulled up on here, so roughly 15 inches wide, 15 inches tall, and about 11 and a quarter inches deep, something like that. So we're going to populate our build with a bunch of parts. So we'll start out by importing our parts here. And I already have them bundled into a platform. Alright, so pulls in all of our parts. They're all over top of each other. Turn off bounding boxes so you can see a little bit easier. So we need to spread all these out and start orienting them for the build. So we'll just do a quick auto placement, get everything spread out. Now we can kind of see what we're looking at here. So with MJF specifically, we always try to point critical holes down. So you can see we've got some parts here that actually have another part nested inside them, so they're a printed assembly. And with something like that, we want to, so this is actually, I know we're going to have bearings pushed into it, so we want to orient those round features vertically in the build chamber. So I'm going to start out with just control picking a couple parts here, and going and telling it to indicate the bottom plane, apply, rotates all those parts, kind of throws them over top of each other. We'll fix that in a minute. We've got two nesting details right here. Again, I know that those holes that are going through those parts, those are critical holes. This one's super critical. It has actually dowel holes in it. We want to try and get those as accurate as possible. So same thing. We want to orient those like so. We've got some parts in here that kind of don't matter as much about orientation. This one here is a cover that's going to go over a flame cut steel detail to hook onto something. So, you know, just kind of looking at the build, looking at how thin all these features are, and knowing what forces are going to be involved. I'm actually going to lay this one down on its side so that the layers run in this direction. I think it's going to make for a stronger part when we're all said and done. So, grab that. Flip that guy over. This part right here I'm actually going to leave. That's actually the orientation I want. It is another print as printed assembly. Now these holes obviously aren't running you know, vertically like I'd prefer, but you can't always get that. Sometimes you're just going to have to deal. So yeah, you know, we'll have to maybe chase those out with a drill bit if they come out a little out of round or something like that. This part right here really, you know, I like the way that it kind of came in. I don't think I'm going to touch that one at all. We're going to leave that one be. And then this part here, and there's another one under there. Again, I like how those came in. I think that's going to work just fine. So leave that alone. And then we have this camera lens right here. Again, this is a print as assembly. I'll translate it here a second so you guys can see it. So you can see this is an assembly. We've got some living hinges, or I'm sorry, living springs built right into the part. So again, I think I want this face laying down. Just kind of looking at the features and everything here, I think having that face up is probably the best bet for the best. You know, have those layers go through those springs so that the layer is continuous through the spring. I think that'll give us a better result. Okay, so now our parts are all kind of mishmashed together. So I want to nest everything. So what we're going to do, before we used auto placement, which is a 2D nester. Yeah, you can see it's yelling about stuff maybe falling outside. So we'll say, yeah, place it outside if you can't figure out how to nest it. So it's a 2D nester. So you can see we ran out of room on our platform to get all of our parts nested in there. But that's why the beauty of using a MJF machine is you can nest in the Z as well. So we have an added plugin for Magics, 3D Nester. This thing is really cool. It's also really expensive. So it does not come with your stock install of Magics. It's an added plugin. So we got all kinds of different options here. Part interval, 5 millimeters, 5 millimeters from the sides. I'm going to leave all that alone. Manually end the nesting process. I'm going to leave that as well. I'm going to go down to advanced. And then go to part settings, and a lot of times we use fixed bottom plane. So that means it's not going to tip the part off of that bottom plane. It's going to keep that fixed. It will go up in the Z. I also like to say, rotation angle 90. This would mean it would only go 90-90 when it's trying to fit stuff together. I actually like to crank that down to 15 a lot of times if parts will allow for it, because it just gives you that much better chance of puzzle fitting everything together. And the name of the game with MJF, just like a lot of 3D printing technologies, you want to keep your Z height as low as possible because Z height drives cost. So we're going to hit run, and it's going to start nesting. Okay, so this is a pretty small build platform, so it went pretty freaking fast. Yeah, everything looks pretty good. We've got a nesting density of 7.76 and a nesting height of 99. And if you look, you can see I have an item on there. That's my tallest item on the build, and the floating stuff in the Z is nested at or right below that, which is good, so I don't have anything driving Z height, which again drives time, which again drives cost. All my parts that need to be oriented with holes in the vertical or Z axis, everything looks good there, so I think we are ready to take and get this into the HP software and get it sent over to the machine. So there is a plugin for Magics that allows you to send jobs directly to the HP machine. We actually just got the software earlier this week, and we haven't worked the bugs out yet. So we have kind of a bit of a ham-fisted way we have to do it right now. I'm going to show it to you guys, and just know that there's a slicker way to do this out of Magics, and this is just how we have to do it for the time being. So I'm going to select all my parts. I'm going to go File, Save As, Save Selected Parts As. And then I'm going to go to where we're doing our builds. We're keeping our builds, build platform data, and I'm going to say Apply to All. And I'm going to hit save, and it's going through and grinding out all of those STLs, so we can see Dropbox is updating here. There's all my STLs. Let's hop over into SmartStream 3D Build Manager. So this is the software that comes with the HP printer. It allows you to pretty much do what Magics does, but it's very lacking in functionality. It doesn't have any great nesting features or anything like that. Not a lot of great repair tools. It's just kind of bare bones, to be honest with you. So we're big fans of Magics here, so we're only using this because we don't have that one plugin working yet. As soon as that's working, we'll probably never touch this again. So we're going to add some parts, make sure I'm in the right folder. I am. Circle all those, open. Again, for some reason, it drops everything a little bit below where it needs to be, so the yellow items are all flagged. Pretty simple fix though. We just turn that on, grab this arrow, just start. Ooh, there we go. Drag it up, and it kind of snaps to the bottom of the machine for you. So now everything's blue, everything looks good. So we are ready to send this out to the printer. We pretty much leave these alone. We always, 99% of the time, run balanced profiles. So yeah, so let's hit send to printer. Yeah, it's fine. We already did that in Magics. Continue. So it's slicing. And sending. There we go. Job report successfully generated. Here's our job report that we can print out, and it goes with the parts so we know what's what, quantities, everything like that. So we're done. So now I'm going to flip over to a POV camera, and I'm going to go wander around the lab a little bit, and we'll get this build running.